Slide 1. Introduction to ESP32-WROOM Dev Board. The ESP32-WROOM is a versatile and affordable microcontroller module created by Espressif Systems. It's extremely popular for IoT projects because it combines powerful processing with built-in wireless communication, Wi-Fi and Bluetooth, meaning you don't need extra modules to connect to the internet or other devices. It has 38 pins that serve many purposes. General digital input-output pins to control LEDs or read button presses, analog pins to measure things like light or temperature, touch-sensitive pins for modern controls without physical buttons, and communication interfaces like UART, SPI, and I2C for talking to other hardware. This broad set of features makes the ESP32 perfect for smart homes, automation, robotics, and wearable technology, giving you flexibility to build almost any connected device. Slide 2. Power and EN pins. Power pins are the heart of the ESP32 board's electrical system. The VIN pin accepts 5 volts, which can come from USB power or an external power supply. This 5V input is then regulated down inside the board to a stable 3.3 volts, which is provided on the 3.3B pin for powering sensors or other low-voltage devices. Ground or GND pins complete the electrical circuit and are crucial for the board and connected components to function correctly. The EN pin, sometimes called the enable or reset pin, restarts the microcontroller when pulled low, essentially turning it off and on again. This is important during programming or troubleshooting. If your ESP32 isn't working properly, sometimes resetting with EN fixes it. Correctly connecting power and ground pins prevents damage and ensures the board runs smoothly. Slide 3. Digital GPIO pins. GPIO pins are the ESP32's main interface with the physical world. These pins can act as either input or output for digital signals, meaning they detect or send only 2 voltage levels: high, usually 3.3 volt, or low, 0 volt. This lets you do simple tasks like turning an LED on or off, reading a push-button press, or activating a relay. Many GPIO pins support PWM, which stands for pulse width modulation. PWM is like a rapid on-off signal that changes the average voltage output, so you can smoothly dim an LED or control the speed of a motor, rather than just turning it fully on or off. It's important to avoid GPIO pins 6 to 11, because these are connected internally to the board's flash memory. Using them could cause your ESP32 to fail to boot or behave unpredictably. Understanding which GPIO pins you can safely use helps you build reliable circuits and avoid hardware conflicts. Slide 4. ADC pins, analog to digital conversion. Many sensors output analog voltages that vary continuously, such as a temperature sensor changing voltage as it gets hotter. The ESP32's ADC pins convert these analog signals into digital values the microcontroller can process. The ESP32 has 2 ADC units, but ADC2 pins share resources with Wi-Fi, so they can sometimes be unreliable when Wi-Fi is active. Therefore, it's best practice to use ADC1 pins for stable sensor readings. These pins measure voltages with 12-bit resolution, meaning the analog voltage is converted into a number between 0 and 4095, allowing precise measurement of sensor outputs. This capability lets you measure things like light intensity, sound volume, or knob positions to make your projects responsive to the environment. Slide 5. DAC pins, digital to analog conversion. Unlike many microcontrollers, the ESP32 includes 2 DAC pins which convert digital values back into analog voltages. This means you can output a voltage between 0 and 3.3 volts to control analog devices directly, like creating audio signals to play tones or music, or sending smooth control voltages to motors and actuators. This is especially useful in audio applications, or when you want to generate waveforms such as sine waves or ramps for advanced controls. With DACs, your ESP32 can do more complex tasks that require variable voltage output, giving your projects a new level of control and interactivity. Slide 6. Touch sensor pins. The ESP32 has built-in capacitive touch sensors on 10 specific GPIO pins. Instead of physical buttons, these pins detect the presence of a finger by sensing a change in electrical capacitance, which happens when your finger approaches the pin. This means you can create sleek, buttonless user interfaces that respond to touch. improving the look and feel of your projects. Touch sensing is useful in devices like smart light switches, touchpads, wearable gadgets, and interactive displays. Because it requires no mechanical parts, touch sensing is also more durable and can reduce maintenance compared to traditional buttons. Slide 7, UART communications. UART, or Universal Asynchronous Receiver Transmitter, is a basic form of serial communication where data is sent one bit at a time. The ESP32 has several UART ports with TX pins for sending data and RX pins for receiving data. This communication is crucial for connecting your ESP32 to devices like GPS modules, GSM modems, Bluetooth modules, or simply to your computer via USB for programming and debugging. When you write code in Arduino IDE and use the serial monitor, you're communicating over UART, making it an essential tool for development and real-time monitoring of your projects. Slide 8. I2C communication. I2C is a two-wire communication protocol using a data line SDA and a clock line SCL. On the ESP32, these are typically on GPIO 21 and GPIO 22. I2C is designed to connect multiple devices to the same two wires by assigning each device a unique address. This reduces wiring complexity and is perfect for connecting sensors like accelerometers, gyroscopes, environmental monitors, or small displays. It's efficient and flexible, making it ideal for complex projects where many modules need to share data lines without interfering with each other. Slide 9. SPI communication. SPI is a communication protocol that uses 4 wires and is faster than I2C, making it ideal for high-speed data transfer. On the ESP32, the SPI pins include MOSI, Master Out Slave In, MISO, Master In Slave Out, SCK, Clock, and CS, Chip Select. SPI is commonly used to connect SD cards for data logging, TFT displays for graphics, and fast sensors or shift registers. Because SPI transfers data quickly and can handle large volumes, it's the preferred method when speed is important, such as in video displays or rapid sensor data acquisition. Slide 10. Important notes and pin usage tips. When working with ESP32 pins, be cautious. GPIO pins 6 to 11 are used internally for flash memory, so avoid using them to prevent crashes or boot failures. Pins 0, 2, and 15 are used during the boot process. If you connect devices improperly to these pins, your ESP32 might not start correctly. Always check your pin assignments before wiring or programming. For components like LEDs and buttons, use current-limiting resistors to protect your board from damage. Good wiring practices, stable power connections, and careful planning will help your ESP32 projects run smoothly and last longer, making your development easier and safer.
Yeah.